Good day, everyone. This is Afnan Jaradat, the head of math department. I'm responsible for teaching grades 11 and 12 IGCSE, as well as grade 12 AHSD. This recording is to solve Statistics 1 January 2025 session exam. Starting from question number 1. Jin has one fair four-sided red die and one fair four-sided blue die. The red die has the sides numbered 1, 2, 3, 4, and the blue die has sided number 1, 3, 5, 7. The discrete random variable R represents the red die, and the discrete random variable capital B represents the blue die. So, write down the name of the distribution of R. To name the distribution of R, it's a fair four-sided die. So, all probabilities equals to each other, which is 1 over 4, because you have a red die side number 1, 2, 3, 4. So each one 1 over 4. So look here, the red outcomes, which is 1, 2, 3, or 4, and its probability equals to 1 over 4, 1 over 4, 1 over 4, and 1 over 4. So equals to each other. So what is the name of this distribution? Which is the discrete uniform distribution. Discrete uniform distribution. Okay. Find the probability that R is less than 3. Look at the table, okay? The probability that R is less than 3, so R equals to 2 or 1. So here, the probability that R equals to 1 plus the probability that R equals to 2, which equals to 1 over 4 plus 1 over 4, so the answer is 2. Write down the value of the expected value of R. The expected value of R is to multiply R by its probability. So 1 multiplied by 1 over 4. 1 multiplied by 1 over 4 plus 2, multiplied by 1 over 4 plus 3, multiplied by 1 over 4 plus 4, multiplied by 1 over 4, which equals to 1 over 4 plus half plus 3 over 4 plus 1, which equals to 2.5. What about the expected value of B? The expected value of B also, I will make it here. Look, the outcome of blue and what is the probability of each one. The probability of 1, 3, 5, and 7, which is the outcomes. Look here. The blue die has numbered what? Each one also 1 over 4 because it's fair. 1 over 4, 1 over 4. So what is the expected value of B, which is 1 multiplied by 1 over 4 plus 3, multiplied by 1 over 4 plus 5, multiplied by 1 over 4 plus 7, multiplied by 1 over 4. 7 multiplied by 1 over 4, and the answer is 1 over 4 plus 3 over 4 plus 5 over 4 plus 7 over 4, which equals to 4. D. Showing you working, find the variance of B. How can I find the variance of B? The variance of B equals to expected value of B square minus the expected value of B square. That expected value of B, that you have it here, this one, which is 4, okay? How can I find the expected value of B square? By finding B square equals to what? B equals to 1, so B square 1. B equals to 3, so B square equals to 9. B equals to 5, so B square 25. B equals to 7, so B square equals to 49. So to find B square equals to what? You need to multiply B square multiplied by each probability. So 1 multiplied by 1 over 4 plus 9, multiplied by 1 over 4 plus 25, multiplied by 1 over 4 plus, and 49 multiplied by 1 over 4. The answer here is 21. To find the variance here, this one, the variance of B equals to, again, expected value of B square minus the expected value of B and all of this one square. expected value of b squared, which equals to 21 minus the expected value of b, 4. So it's 4 squared equals to 21 minus 16, which equals to 5, which equals to 5. Okay? This one, D. Jin rolls each die once. What is the probability that R plus B is less than or equals to 5? R plus B, you need to add the outcomes of R and the outcomes of B, okay? To find the sum of these outcomes must be less than or equal to 5. Must be less than or equals to 5. Look here. So, red, the outcomes of red, which is 1, 2, 3, 4. And the outcomes of B, which is 1, 3, 5, 7. Okay. I need to add R plus B and to get the answer less than or equals to 5. So, look here. If you add 1 plus 1, 1 plus 1, the answer is 2. And 2 is less than or equals to 5. So, take 1, 1, 1 red and 1 blue. Okay? 1, okay, here. Red, blue. I will take 1, 1. The sum is 2. 2 is less than 5. So, accepted. The other one, if you add 1 plus 3, 1, 1, and 1, 3, 1 plus 3, 1 red, and 3 blue, you will get 4, which is less than 5. Accepted. Okay? Then 1, 5, which equals to 6. 6 is greater than 5. Go to 2. Okay. 2 plus 1. 2 plus 1, which equals to 3, and 3 less than 5. If you add 2, okay, 2 plus 1, accepted. 2 plus 3 equals to 5. And you need all the values of R plus B that less than or equals to 5. So equals 2 plus 3. So take 2 red and 3 blue, which equals to 5, which equals to 5. So accepted. Okay, going to 3. After that, 2 plus 5, which equals to 7, so it's greater than 5. Go to 3. 3 plus 1, 3 plus 1 equals to 4. So 3 red and 1 blue. 3 plus 1 equals to 4, which is less than 5, accepted. And 3 plus 3 equals to 6, not accepted. Go to 4. Go to 4. 4 plus 1 equals to 5, and you need to take all what's less than or equal. So 4 and 1, which equals to 5. 5 equals to 5, so accepted. 4 plus 3, which equals 7. 4 plus 5, 9. 4 plus 7, 11. You need only what's less than or equals to 5. So only these outcomes. The question about to find the probability 1, which is 1 over 4, the probability of 1 in red, this one, 1, which is 1 over 4. 1 for blue, which is also 1 over 4. What about 1, 3? 1 over 4, 1 over 4. 2 and 1. 1 over 4, 1 over 4 for each red or blue. So the probability here that R plus B, the probability that R plus B is less than or equals to 5 equals to how many outcomes? 1, 2, 3, 4, 5, 6. 6, okay? So 6 multiplied by 1 over 4 times 1 over 4, which equals to 6 divided by 16, and simplest form by dividing each one by 2, 3 over 8, the final answer. So the probability that R plus B is less than or equals to 5 in details equals to 6 multiplied by 1 over 4 times 1 over 4, which equals to 3 over 8. F, I need to find the probability that R square is less than B. So I need R square to be less than B. Okay, so E, the probability of R plus B, sorry, F. Okay, F, the probability that R square less than B. Okay, so I have R, which is 1, 2, 3, 4. I need R square, which is 1, 4, 9, 16. And also I need B here. Look, I need R squared and B. B, 1, 3, the outcomes of B. 1, 3, 5, and 7. The question is just about the probability that R square less than B. R square less than B. How can I find that R square less than B? Okay, look here. R square, if R square is 1, here, R square is 1. 1 is less than 3. 1 is less than 5. 1 is less than 7, right? So R square and blue, and I need R square to be less than B. So 1 less than 3, 1 less than 5, 1 less than 7. And also look at 4, this one, 4. 4 is less than 5 and less than 7. 4 also, if R square is 4, which is less than 5, and 4 less than 7. Only these outcomes. So how many outcomes? It's 5. So 5, you need to multiply it by the probability, which is 1 over 4 times 1 over 4 also. So equals to 5 over 16. 5 over 16. Okay. A question G, okay, the random variable D is defined as a magnitude of the difference between the score of red dye and the score of the blue. So I need the difference between blue and red, and the magnitude of the difference between the score of a red and a score of blue. Okay, the table shows the commutative distribution. So F, you have the commutative distribution, and the question to showing you're working, find the value of P. How can I find the value of P? And P is a cumulative distribution. This one, cumulative. Cumulative, so I need to find the probability of 4 plus 3 over 4, because it's cumulative, 3 over 4, which is this one, okay? The cumulative, the probability of 4 plus the cumulative of a 3. How can I find the probability of 4? Again and again, D is the magnitude of the difference between the scores of red and the score of blue. So I need, again, red and blue. Red, which is 1, 2, 3, 4, and the blue, which equals to 1, 3, I think 7 and 9. Sorry, 5 and 7. Yes, 5 and 7. 5 and 7. Look here. I need the difference between the scores to be 4. To be 4. So you need to, if blue equals to 5 and the red equals to 1, so the difference equals to 5. Okay? Blue equals to 5, okay, and 7. If blue equals to 7 and red equals to 7 minus 3 to get, yes, if blue equals to 7 and the red equals to 3, sorry, what is the difference? Difference is, I need it to be 4. Yes, this one equals to 4, sorry. 4. 7 and 3 to be 4. Okay? Only if blue equals to 5 and red equals to 1, the difference, the magnitude of the difference between the score of red and the score of blue is 4. And the other one is if the blue is 7 and red is a 3. The difference will be 4. So what is the probability here? What is the probability here? The probability that the difference equals to 5 equals to 2 multiplied by 1 over 4 times 1 over 4. 2, because you have this one and this one as outcomes, multiplied by the probability of each one, which is 1 over 4, 1 over 4, 1 over 4, 1 over 4, which equals to 2 over 16, which equals to 1 over 8. This one is the probability that D, the difference is 4. This one, the probability, I'm sorry, that the difference is 4, not 5, 4. Okay, so 1 over 8, you need to add it to 3 over 4 to get the answer, which is 1 over 4 plus 3 over 4, which equals to 7 over 8. The answer is 7 over 8. This one, you need to make it the same denominator by multiplying this one by 2 by 2, 7 over 8. Yes, that's correct. Okay, so G equals to 7 over 8 because I need the cumulative, not the probability. If the question about just the probability, the answer is 1 over 8. That's all about question number 1. Going to the other question, which is question number 2, which is about stem and leaf diagram. Yes. As a part of investigation, Bobby collects a sample of 47 observations X. The results are shown in the following stem and leaf diagram, where A is a constant. If the question about stem and leaf, you need to make 2 steps. Number 1, to read the key. To read the key. Look at the key. The key 3/2 means 0.32. It's very important to read the key. That's step number 1. Step number 2, to make cumulatives. So starting from 5, then add 5 plus 10 equals to 15. 15 plus 11, which equals to 26. 26 plus 6, 32. 32 plus 7, 39. 39 plus 5, which equals to 44, and 44 plus 3, which equals to 47. 47, which equals to 47 observations. Okay. Find the range of these observations. Okay. How can I read the stem and leaf? By using this key. So 3/2 means 0.32. So this one is 0.21, 0.22, 0.25, 0.27, 0.27, 0.30, 0.32, and so on. Okay? So to find the range equals to the maximum minus the minimum point. And here the maximum, which is this one, and the minimum is this one. How can I read it? It's 0.87 minus 0.21, okay, which equals to 0.66. Find the value of the median of these observations. The median when n plus 1 divided by 2. So I have 47 observations plus 1 divided by 2, which equals to 48 divided by 2. So the position is 24th. 24th. So go to the cumulatives. Okay, this one is 26. I need 24. So 26, 25. This one is the 24th. Okay, how can I read it? 0.48. 0.48. Given that the interquartile range of these observations is 0.31, find the value of A. Okay, so C. The interquartile range equals to third quartile minus first quartile. The interquartile range, which is 0.31, equals the third quartile. I can find it by making 3 over 4 multiplied by the number of observations, which is, 47, which equals to 35.25, okay, as a position, and you need to round it up always. You need to round up the first and the third quartile. It will be 36. Okay, so I need this one, and I have here 39. So 39, 38, 37. So this one is 36. This one is 36 as a position. Okay, how can I read it? It's 0.6A. Okay, and I need to find the first quartile by making 1 over 4 multiplied by 47 to get 11.75, and I need to round it up. It will be 12. How can I find 12? It's this one, 5, 6, 7, 8, 9, 10, 11, 12. So it's 0.35. It's 0.35. So I have 0.31 as interquartile range. So 0.31 equals the third quartile minus 0.35. Take 35 to the side. It will be 0.31 plus 0.35 equals to the third quartile. So the third quartile equals to 0.66. 0.66. I need A. Look at A. It's 0.60A. So don't miss to write that A equals to 6. Okay? This one A. Look here. 0.66. This one A. So A equals only 6. Okay. Bobby calculates the following statistics from these observations that the sum of x equals to 23.72 and the sum of x squared equals to this one, show that the standard deviation of these observations is 0.17 0.176 to three significant figures. Okay, how can I find the standard deviation? D. The standard deviation equals to square root of the sum of x squared divided by n minus the mean square. You have sum of x, you have sum of x squared, and you have n, that's 37. So sigma, which is the standard deviation, equals to sum of x squared, which is 13.4228 divided by 47 minus the sum of x, which is 23.72 over 47 square. Okay, so the standard deviation equals to 0.176 to three significant figures. Okay, to three significant figures. Going to a question E. Okay, Bobby now collects 18 more observations. So you have 47 observations and to add 18 more observations. The 18 more observations, look here. The 18 more observations, which is why from the same investigation. E using all 65 observations, the 65 observations, which is the 18 plus the 47 observations. The sample mean is 0.502 and the sample standard deviation is 0.204. Show that the sum of y equals to this one and showing you where you can calculate the sum of y squared. So going to EI, how can I find the sum of x? I have mean. Okay, I have the mean for the 65 observations. So the sum of x plus the sum of y over the 65 observations, over all observations, over the total number of observations must equals to 0.502. I have this one, which is here, to check it, okay, this one, 0.23.72. Okay, this one like this, yes, okay. I have that x equals to, sum of x equals to 23.72, adding to sum of y out of 65 equals to 0.502. To find the sum of y, you need to multiply 0.502 multiplied by 65, all of this one to subtract it from 23.72. This one equals to the sum of y. So the sum of y must equals to 8.91. 8.91. How can I find the sum of y squared? I also have the standard deviation. And the standard deviation for the standard deviation of the 65 observations equals to square root of what? Square root of sum of x squared plus sum of y squared over 65 minus the mean of the 65 observations, which is this one, 0.502 square. Okay, I have the standard deviation which equals to 0.204 to find the sum of x squared that you have it already. 13 points, okay, this one equals to 13.4228 plus the sum of y squared divided by 65 minus 0.502 squared equals to 0.204. Okay, to find the sum of y squared equals to what? You need to square both sides. Okay, then square root with square, it will be 0.204 square plus 0.502 square. Okay, you need to multiply it by 65. Then for all this one to subtract, to take 13.4228 to find the sum of y squared, which equals to 5.6625, which is to three significant figures, equals to 5.66. 5.66 to three significant figures. Okay? So from question number 2 to question number 3. From question number 2 to question number 3, which is about a tree diagram. Tree diagram. Okay. Question number 3. Okay. Question number 3. A factory makes rugs and blankets from wool or cotton or a polyester. 30% of the items made are rugs and 70% of the items made are blankets. So look here at the tree diagram. To complete the tree diagram, you have rug and blanket, then wool, cotton, and polyester for each one. So 30% of the items made are rugs and 70% of the items are a blanket. So this one here, I need to write how rugs and a blanket. Let me make it like this 0.3 and 0.7. Okay, right. Okay, like this. No, I have. Okay, wait. Like this. Okay. 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 Look here. 30% are rugs, so this one is 0.3, and 70% are blankets, so this one 0.7. Check if the addition is 1. Yes, 0.3 plus 0.7, which equals to 1. For rugs, 60%, this one done. 60% of the rugs are made from wool. So 60%, this one, it's 0.6. And 35, this one done. 35% of the blankets are made from wool. So blankets and wool, this one, which is 0.35. Then 10% done. 10% of the rugs are made from cotton. 10%, so 0.1 from rugs. Done. 20% of the blankets are made from cotton. So 20% of the blankets are made from cotton, 20%. So this one is 0.2 done. The rest of the rugs and the blankets are made from polyester. So how can I find the rest? You need to know that the sum of all of these must equals to 1. So 0.6 plus 0.1, which equals to 0.7. So what's left is 0.3. And this one 0.35 plus 0.2, which equals to 0.55. You need to add 0.45 to make it equals to 1. And this one also must equals to 1. So complete the tree diagram. Completed. Going to be okay, going to be. The question is to find the probability that the item selected is not made from wool. Not, okay? Not from wool. Okay. Look here. Make a rug wool. This one, which is, sorry, RW. This one RC, which is rug and cotton. Rug and polyester, RP. This one exactly the same. It's blanket W and blanket cotton and blanket P polyester. Okay? The question is, find the probability that the item selected is not made. Not made. So not wool, not rug wool or blanket wool. Okay? So which is 1 minus, okay, which is 1 minus the probability of wool. 1 minus 0.3 multiplied by 0.6 plus the other one, this one, which is 0.7 multiplied by 0.7 multiplied by 0.35. Okay, the answer is 1 minus 0.425, which equals to 0.575. Okay, or other way, to add rug cotton plus rug polyester plus blanket cotton plus blanket polyester. Okay, other way is to add 0.3 multiplied by 0.1 plus this one, 0.3 times 0.1. Okay, then 0.3 times 0.3. 0.3 times 0.3 plus, then blanket 0.7 multiplied by 0.35, 0.7 multiplied by 0.35, then to add also 0.7 times 0.2. 0.7 multiplied by 0.2, the answer also is 0.575, the same answer. Okay? The last question, this one BI. The last question, which is B double I. Look at B double I. B double I, given that, so it's conditional that this item is not made from wool. Find the probability that it is a blanket. Find the probability that it is a blanket given that it's not wool. Okay? Tamam. So again, given that, okay. Given that, the meaning of given that, it's conditional. Conditional probability. Conditional probability. Probability. So what is the probability that, it is a blanket? Okay. Given that it is not wool. Okay. Which equals to the probability that its blanket intersects its not wool over the probability of not wool. Okay, so what is the probability that it's a blanket and not wool? What is the probability that it's a blanket and not wool? So a blanket, this one, okay, wait a minute. I'll make it again. This one 0.7, right? And this one 0. 0.3, 0.7, 0.6, 0.1, 0.3, 0.35, 0.2, and 0.45. I need it to be blanket, this one, but not W. So I need to take C cotton and polyester by multiplying 0.7 times 0.2 multiplied by 0.7 multiplied by 0.45. So the numerator will be 0.7 multiplied by 0.2 plus 0.7 multiplied by 0.45 over the probability that it's not wool, that is part I, okay, this one, which is 0.575. The answer is 0.7 times 0.2 plus 0.7 times 0.45 equals to 0.455 divided by 0.575. The answer is 0.791304, which equals to three significant figures, 0.791. This is the final answer. So the probability that it's not wool and it's a blanket, given that, a blanket, given that it's not a wool, is equal to 0.791. That's all about question number 3. Going to question number 4. Question number 4. Question number 4, which is about a pet food, okay? The sample of 3 new flavors of a cat foods, ABC, to each 100 customers. So the number of customers is 100. These customers are surveyed to find out whether or not their cat likes each flavor with the following results. 40 cats like A, 45 cats like B, 50 cats like C, 19 cats like both A and B, 20 cats like both A and C, 22 cats like both B and C, and 12 cats like all 3 of these flavors. Using these results, complete the Venn diagram. Also, always, if you need to start filling the Venn diagram, you need to start from the 3 of these flavors. You need to start from the common between 3 events. So 12 cats like this one 12, here 12, which is the intersection between the three circles. Then go to the intersection between two circles. So this one, number one, to fill three circles, the common or the intersection between the three circles. Then fill the intersection between two circles, which is AB, AC, BC. Okay, so 19 cats like both A and B. Going to A and B, 19, which is here, 19. Okay? Between A and B, you have 12 and you need it to be 19. So 12 plus what equals to 19? No, it's 12 plus 7. 12 plus 7. Okay, now A and C, you have 20 cats like A and C. A and C, 20 cats. So 20 cats, you need the intersection between A and C, this one, the intersection between A and C, to be 20. You have inside it 12. So what's left? 8. Okay, and this one, okay, this one, okay, 22 cats like both B and C. So the intersection between B and C, which is this region, okay, you have a 12 and you need it to be 22, so you need 10. You need 10. Now go to A, B, and C. 40 cats like A. So you need to be the number of elements inside A to be 40. You have 7, 12, and 8. So A, inside all the circle of A, you need only 40. So it's 40 minus 7 plus 12 plus 8. Okay, so this one equals to 40 minus 27, which equals to 13. And inside circle B, 45 cats. So 45, you need to subtract from 7, 12, and 10. Minus 7 plus 12 plus 10. Sorry, which equals to 45 minus 29, which equals to 16. And the last one, which is C, 50 cats like C, so 50, you need to subtract from 10 plus 12 plus 8, so which is 50 minus 30, which equals to 20. This one is 20, and don't miss the number outside circles, which equals to 100 customers minus all what's in between circles. So this one, which is 100 minus 13, minus 7, minus 12, minus 8, minus 16, minus 10, minus 20, which equals to 14. So the number which is outside is 14 by subtracting 100 minus the sum of the numbers which is inside circles. So using these results, complete the Venn diagram. Completed. Okay, going to B. Okay, look at B. B, determine whether or not a cat liking flavor A is independent of it liking flavor C. Okay, like this one. So B and C, A and C. A and C are independent or not. Okay, so B, the meaning of independence between A and C, that probability of A multiplied by probability of C equals to probability of A intersect C. So what is the probability of A? All what's inside circle A, which is 40, divided by all, which is 100, multiplied by probability of C, which is all what's inside circle C. How many elements? Which is 50, divided by 100. Is it equals or not probability of A intersect C? So the intersection between A and C, which is where A and C, this one, okay, which is 20 over 100. 40 multiplied by 50, which equals to 200 out of 10,000, 0.2, which equals to 20 over 100, which is also 0.2, so independence. Independence equals to each other, so independence. Okay, going to C. See, one of these 100 cats is chosen at random. Find the probability that it likes only one of the three flavors. One of the three flavors. Okay. So A only, or B only, or C only. Okay. Or look at or any probability is plus. Okay, look at or. So 13 over 100, 13 cats like only A, and 16 cats like only B, and 20 cats like only C. So 13 over 100 plus or 16 over 100 or 20 over 100. Okay, the answer is 49 over 100, so the probability is 0.49. The probability is 0.49. This one CI. Double I, double I, given that it likes flavor C, find the probability that it also likes flavor B. Okay, given that, look at given that. Okay, given that it likes flavor C, find the probability that it is also like flavor B. So you can read it. Find the probability that it also likes flavor B, given that it likes flavor C. So, okay, this one like this. So, part C double I, C double I. What is the probability that it likes B given that it likes C? Given that, so it's what's the probability of B intersect C that the cat like B and C over the probability of C. Probability of B intersect C, which equals to B and C, which is this one. It's 22 over 100. 22 over 100 over probability of C, all what's inside circle C, or you can take it from this one, which is 50 over 100. 50 over 100, so the final answer is 0.44. The final answer is 0.44 by dividing 22 over 100, which is 0.22, divided by 0.5 equals to 0.44, which equals to 0.44. Okay. From question number 4 to question number 5. To question number 5. Okay. Question number 5, which is about normal distribution, about recycling center measures the weight of a glass deposited by a public each day. The weight of a glass S kilogram deposited at the recycling center in a day during the summer can be modeled by S is distributed normally on 750 square. So 700 is a mu, the mean, and 50 is the standard deviation. 50 square is the variance, and I don't need variance. I need the standard deviation and the mean. So the mean equals to 700 and the standard deviation equals to 50. Using standardization and showing you working, find the probability that in one random selected day during the summer, the first question, more than 640 kilogram of glass is deposited at the cycling center. So, question number 5A, okay, what is the probability that S is greater than 640, more than 640 kilogram? So I need to go to the table. I need this one to be Z and less than. Z and less than. So probability of minus the probability of S less than 640, because this one is greater than, to make it less than 1 minus the probability, then it's 1 minus the probability that Z less than 640 minus mu over standard deviation to convert it to Z. I don't need S to go to the table. I need Z. So it's 1 minus the probability of Z less than 640 minus, don't miss that the first number is mu, the mean, and this one is the variance. So you need the standard deviation, which is 50. So 640 minus 700 divided by standard deviation, which is 50. So this one, which is 1 minus the probability of z less than negative 1.2, less than 1, uh, okay, less than negative, okay, which is 1 minus the probability of z to be positive, it's 1.2. You need to convert from negative to positive by using this one, okay? Or from this one, it's s greater than 640 to convert it to z. Probability of z greater than negative. Greater than negative, it's also this one. So negative, like this, it will be 1 minus 1 plus probability of z less than 1.2. 1 minus 1. So you need the probability of z less than 1. How can I find the probability of z less than 1? Probability of z less than 1, 0.2. Less than 1.2. Look at the table 1.2, z 1.2. Okay, this one, z 1.2. So the area is 0.8849. The area is 0.8849. Okay. Again, I, the probability that z less than 1.2, which equals to 0.8849 to three significant figures, which is 0.885. Okay. The other question is 700 kilogram of glass correct to the nearest 50 gram. It's deposited at the recycling center. So corrected to the nearest 50 grams. So you need to find the upper and the lower bounds. 50 gram by number one dividing 50 divided by 2, which equals to 25 kilogram. To add the 25 kilogram to 700 to find the upper limit, which is 725, and to take 25 from 700 to find the lower limit, which is 625. So you need to use standardization to find the probability that uh, that 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 selected day during the summer, the probability I need the area or the probability between 625 and 725. So double I is to find the probability 625 less than S less than 725. Okay, by subtracting probability of S less than 725 minus the probability of S less than 625. So upper limit minus lower limit. This one you need to convert it to Z by using probability of Z less than 725 minus mu, and mu equals to 700 divided by 50. Also this one, again, this one mu and this one sigma, this one mu, minus the probability that z less than 625 minus 700 divided by 50. This one, probability of z less than 25 over 50, which equals to 0.5, minus 625 minus 700, which equals to negative 25, negative 25 over 50, probability of z less than negative half. Less than negative, you need to convert it. So probability of z less than half minus 1 minus the probability of z less than half. So what is the probability that z less than half? So you need to go to the table. You need to go to the table to find that the probability of z less than half equals to 0.6915 minus 1 minus 0.6915. Okay, and the final answer is 0.6. Okay, the final answer is 0.383 to 3 decimal places. 0.383 to 3 decimal places. Just to check with you that z less than half equals to what? Okay. Uh-huh. If z equals to half, this one half, okay? This one half. Z equals to half, so the area is 0.6915. Okay? Okay. So A, I and double I done, going to B. The weight of a glass W kilogram deposited at the recycling center in a day during the winter can be modeled by winter. W is distributed normally around mu and sigma square. Given that the probability of W is greater than 680 equals to 0.0668 and the probability of W that less than 599 is equals to 0.3, find two equations in terms of mu and sigma and double I to showing you working find the value of mu and lambda. Okay. If you have the area, look here, if you have the area, and this one, if you have the area, you need to find what is the sign of Z by. If by making this method, if this sign is greater than and this area is less than half, so greater than, less than, so Z is positive. Okay, if it's greater than and greater than half, Z is negative. Greater than and this one is less than half, the area is less than half, so Z is negative. Look at this one. If the sign is less than and this one also less than, so less than, or greater than, you need to know that Z is negative. If the sign is greater than and the probability or the area is okay, if the sign is greater than and the probability is less than half, so this one is positive. If it is greater than and the answer is greater than half, the probability is greater than half, so Z is negative. So here Z is positive, and in this one Z is negative. Z is negative. So taking this one here, the probability that W is greater than 680 equals to 0.0668. Okay. This one, it will be what? 0. W, yes, probability of W is greater than. So this one is greater than, less than. You need to convert greater than to less than by making 1 minus the probability of Z less than 680 minus mu over sigma. And the question is to find mu and sigma equals to 0.0668. Okay, greater than, so you need to convert it using this one. 1 minus the probability of less than. Taking this probability to this side and taking the probability of 680 to the other side, it will be 1 minus 0.0668 equals to probability of Z less than 680 minus mu over sigma, which equals to 0.9312 equals to probability of Z less than 680 minus mu over sigma. To take this one outside parentheses, you need to find if the area is 0.9312, Z equals to what? Z equals to what? This one from the table, okay? It will be a 0.931, which is 1.5, which is 1.5, and Z is positive, okay? So equals to 680 minus mu over sigma. So this one is the first equation. I find equations, just to find equations in terms of mu and sigma. This one, the first equation. What about the equation of the probability of W is less than 599 equals to 0.3? Exactly the same, it's less than. So don't miss that Z is negative here, okay? It's very important. Now to convert it, so the probability of Z less than 599 minus mu over sigma equals to 0.3. Okay, so Z less than, this one equals to 0.3. So less than again, so Z is negative. Remember here that if Z is negative, so this one is negative, less than negative, so also it's 1 minus. 1 minus the probability of Z less than 599 minus mu over sigma equals to 0.3. Take 0.3 to the side, take this one to the side, it will be 1 minus 0.7 equals to probability of Z less than 599 minus mu over sigma. 1 minus 0.3, which equals to 1 minus 0.3, I'm sorry, equals to 0.7, which equals to probability of Z less than 599 minus mu over sigma. Okay? Remember here that I need to take this one outside parentheses if I have z. So go to the table, take 0.7 as area to find z equals to what? So z here will be 0.52, and don't miss that z is negative. Z is negative. Okay, it's very important to find that z is negative. Here, to write negative, it's 599 minus mu over sigma, and this one is the second equation. So find two equations in terms of mu and sigma. This one, the first equation, and the second equation is here. Hence, showing you working, find the value of mu and the value of sigma. Okay? The value of mu and the value of sigma. Okay? So, the value of mu and sigma. Okay. You have now two equations. The first one, which is 680 minus mu over sigma, which equals to 1.5. So make a cross multiplication. It will be 1.5 sigma equals to 680 minus mu. Take mu to the side and take this one to the side. So mu equals to 680 minus 1.5 lambda. The second equation also, which is a negative 0.52 equals to 599 minus mu over sigma, cross multiplication. So it's negative 0.52 sigma equals to 599 minus mu. Take mu to the side and take sigma to the side. So mu equals to 599 plus 0.52 sigma. So take this one as the second equation. So mu equals mu equals. So you need to make simultaneous equations by making these two equations equals to each other. So now 599 plus 0.52 sigma equals to 680 minus 1.5 sigma. To find sigma, put constants in one side and others in the other side by taking 1.5, negative 1.5 to the other side and 599 to this side. It will be 0.52 sigma plus 1.5 sigma equals to 680 minus 599. 599. So this one plus 1.5, which equals to 2.02 sigma equals 680 minus 599, which equals to 81. Yes, that's correct. Divided by 2.02, divided by 2.02. So sigma equals to 40.09, which is about 40. 40.09, which is about 40. If you have sigma, how can you find mu? By substituting sigma in any equation, this one or this one, it's up to you. By substituting sigma in equation mu equals to 680 minus 1.5 multiplied by 40, the answer 40.09, the answer will be 619.80 about 619.85, so which is 620 to three significant figures, which is 620, and the sigma in two significant figures because it's sigma. Because it's sigma, you need to write it in two significant figures, and mu to three significant figures because it's 620. So it's 620. Okay, so from question number 1 to question number 6. From question number 5 to question number 6. To question number 6. The question number 6, okay. Going to question number 6. Question number 6, as a part of a selection process, applicants for a TV game shall have to take a test and then to complete a task as quickly as possible. The test is scored W, and the time taken to complete the task is 10 minutes. That's very important to know. W and T is referred to what? So W is the test score, and T minutes, in minutes, it's the time taken to complete the task, are recorded for each applicant. The summary statistics below represent the data of the random sample of 30 applicants. So the number of elements is 30. SWT equals to negative 1.6, negative 1648.83, as WW equals to 2396.97, and the sum W equals to 839, the sum of T equals to 635, the sum of T squared equals to 14,837. Show that the product moment correlation coefficient for these data is negative 0.901 to 3 significant figures. Okay. A, question number 6A, the product moment correlation coefficient equals to SWT over the underscore root SWW times STT. I have SWT, which equals to negative 1648.83. I have SWW, which equals to 2396.97, and I need STT, which equals to the sum of T square minus the sum of T square over N. The sum of T square, which is this one, 1480, 14,837, minus the sum of T, which is 635 square divided by N. N equals to 30 applicants. So over 30, the answer is 1396.166. Just substitute it instead of this one. So the product moment correlation coefficient equals to negative 1648.38 over the sum of, this one 83, divided by SWW, which equals to 2396.97, multiplied by STT, which equals to 1396.166. The final answer is negative 0.9013136, which is about negative 0.901. Show that it's shown. A scatter diagram of T, again, is W, is plotted for this data. State two features of the graph that you would expect to see given the correlation coefficient in part A. The correlation coefficient, which is negative 0.19. So if the product moment correlation coefficient is negative, so as W increase, T will decrease. Okay? As W increase, Z will decrease. So the product moment correlation coefficient is negative. Okay? So it's like this. It goes down. This one is T and this one is W. W, the test score, and T is the time taken to complete the task. So if W increase, look here, T will decrease. So if W increase, T will decrease. Calculate the equation of the regression line of T on W in this form. So this one is the regression line equation. How can I find the regression line equation? I need to find B, the first step to find B, and B here, which equals to SWT over SWW, because W is the x-axis, which is SXY over SXX. This one, WW, which equals to SWT, this one, WW, this one, so it's negative 1648.83 divided by 2396.97. So B equals to negative 0.68788, which is about negative 0.688. So B equals to negative 0.688. The second step after finding B, you need to find A. And A equals to T bar minus BW bar. Okay, again, because y-axis is t and x-axis is w. This one, a equals to y bar minus bx bar. So instead of y bar, it's t bar. Instead of x bar, which is w bar. How can I find t bar and w bar? This one, the sum of t over 30 equals to t bar. So equals to t bar, which equals to 635 divided by the number of applicant, which is 30, minus b, that I found it here, b, which is negative 0.68788. You need to multiply it by w bar, which is also the sum of w over n, the sum of w, which equals to 800, this one, okay? 839 divided by 30. So the final answer of A is 40.404. 40.404. So T equals to what? T equals to 40.4 minus B, which equals to 0.688. Look at negative B, negative. The sign of B is negative. 88W. So this is the regression line equation. The regression line equation. Okay, D. This one, C. Yes, D. Give an interpretation of the gradient of the regression line. Okay. The final form for this one, which is t equals to 40.44 minus 0.688 to three significant figures multiplied by w. And the question D is to give an interpretation of the gradient. The gradient for this equation, the gradient is delta t over delta w, okay? Delta t over delta w. And t is about the time taken to complete the task. T is the time taken to complete the task. And W, which is the test score. The test score. Okay. Where is the gradient here? The gradient is the coefficient of W. So this one, which is 0.688 over 1. 0.688 over 1. So 0.6, okay. So as a test score increase, by 1, okay, the time will decrease. This one's negative. The time will decrease by 0.688 minutes. Okay, so D, the answer is as a test score, which is W, as test score will increase by 1, as a test score increases by 1, the time taken to complete the task will decrease or decreases by 0.688. Okay, this one is the answer of D. I'm going to E. Test score W. Okay, the test score. Okay, E. The test score W was a score out of 50. The manager of the selection process now decides to double all the values of W. Just to double all the values of W to make them into percentages. The manager then recalculates the product moment correlation coefficients and the equation of the regression line. State for each of the following whether the value would increase or decrease or stay the same as a result of applying this change. What about the product moment correlation coefficient? In this case, the manager only double the values of W, okay? And you know that product moment correlation coefficients are affected by outliers, right? And here there's no outlier, just multiply the product moment correlation coefficient only measure a linear relationship. So if you divide W by 2, so it's not affected the product moment correlation coefficient. So stay the same. Stay the same. The second one, which is the magnitude of the gradient of the regression line, the magnitude of gradients. You know that the gradient, which is delta T over delta W, the manager multiplies W, only W, doubles the value of W. So W, now it's 2W. Just multiply, just double the value of W. So this one will be delta T over 2 delta W. So this one will increase. Will decrease. Will decrease the half. Okay? Will decrease half from delta T over delta W to delta T over 2 delta W, because the manager multiply only the values of W to 2W. The t-intercept of the regression line, how can I find the t-intercept? By making W equals to 0. So W equals to 0 or 2W equals to 0. So this one also not affected. So it stay the same. This one also stay the same. You will multiply W by 0, and if W equals to 0, if you multiply any value by 0, it will be 0. So W equals to 0 and 2W must equals to 0. So this one also stay the same. This one also stay the same. Okay, going from this question to question number 7. To question number 7. Okay, question number 7, which is about... Okay. Question number 7, a farmer supplies a cabbage to a local supermarket. The supermarket manager takes a random sample of 200 of these cabbages, and the weight of each one is recorded. The weight of the cabbage in the sample are summarized in the following box plots. Okay, looking at this box plot, it's about symmetrical. It's about to be symmetrical. Use a linear relationship interpolation, use a linear interpolation to estimate the probability that randomly choose a cabbage from this sample has the weight is less than 570. Where is the location? Where is the position of 570? 570, which is about to be here. This one, 570. So 570, which is between the second and the third quartile. The second and the third quartile. And the question is to use interpolation. So it's between 550. This one is 570, which is between also 650. So the location or the position is here, which is 570. This one, 550. This one is 650. 550, which is the second quartile, so which is half of the data. And 650, which is the third quartile, so it's 0.75 or 3 over 4 from data. I need this one equals to what? To find the estimated probability of less than 570, less than 570. So interpolation, 0.75 minus half divided by question mark over half must equals to 650 minus 550 over 570 minus 550. So 0.75 minus 0. Half equal 0.5 equals to question mark minus 0.5 must equals to 650 minus 550 over 570 minus 550. This one, which equals to 0.25 divided by question mark minus 0.5 must equals to 100 divided by 20. A cross product 0.25 multiplied by 20 divided by 100 plus half equals to question mark. So question mark here equals to 0.55. Question mark equals to 0.55. So the probability that randomly selected the probability that a randomly chosen cabbage from the sample has a weight of less than 570 is 0.55. The supermarket manager takes the quartiles from this sample and now decided to classify the cabbage that weight is at least 30 quartile plus 1.5, 30 quartile minus 40 quartile as extra large. Find the minimum weight. This one very easy. Third quartile, which is 650 plus 1.5 multiplied by 650 minus the first quartile, this one, the first quartile, which is 450, equals to, the answer of B is 950. So this is the answer, 950. The supermarket manager assumes that the weight of cabbage supplied to the supermarket may be modeled as a normal distribution. Explain whether or not box plot supports this assumption. Yes, sure. It's supports this assumption because it's about to be symmetrical. Look at the box plot here. It's symmetrical. So explain, yes. So the answer is yes. The answer of C, yes, support, because the box plot is symmetrical. Okay. The farmer records the weight of every cabbage harvested from a field and classified the weight is more than 2 standard deviation above the mean as an outlier. Assuming that the weight of the cabbage from this field may be modeled by the normal distribution, find the probability that a randomly selected cabbage harvested from the field would be classified as an outlier using the farmer method. Okay. So D, okay, this one like this, D, okay, normal distribution, this one mu, and the question is more than 2 standard deviation above the mean. So this one is 2 standard deviation above the mean. Okay, above the mean as an outlier. Again, more than. So this area is an outlier. This one is an outliers. The probability that a randomly selected cabbage harvested from the field would be classified as an outlier. So I need to find the probability of Z greater than 2. This one is the standard deviation, 2. Z greater than 2 equals to what? If Z is greater than 2, which is the more than 2 standard deviations above the mean, so which equals to 1 minus the probability that Z is less than 2. So you need to go to the table and to find if Z equals to 2, what is the area? The area will be 0.9772. So the probability of outlier is 0.0228. This one is the probability. This one is the area when Z equals to 2. When Z equals to 2. So this is the answer of part D. Yes, part D is 0.0228. The mean weight of the cabbages harvested from the field is 560 grams. This one is the mean. Given that the cabbage with a weight of 1,000 grams is classified as an outlier, this one is an outlier. Find the maximum possible value of the standard deviation of the weights of the cabbage harvested from the fields. So Anna, I have that probability of X is greater than 1,000. Okay, equals to what? This one is outlier. So equals to what? What's the probability? This one, 0.0228. Probability that Z is greater than 1,000 minus mu, which is 560, divided by the standard deviation, equals to 0.228. I need it to be less than, so it's 1 minus the probability of z less than 1000 minus 560, which equals to 440 over sigma equals to 0.0228. This one also 0.0228. Okay. What is the okay, I need to take this one 0 point, okay, what is the z if the area is 0.0228? You need to take this one to the side and this one to the side, but you know that if the probability or the area is 0.0228, z is 2, okay? Here you can find that 1 minus 0.0228 must equals to probability of z less than 440 over sigma. Okay, to find this answer, what is z? Z equals to what for this area? It will be 2 because this one greater than 2 equals to 0.0228. Okay, equals to, now if z equals to 2, you can take this one outside. Parenthesis 440 divided by sigma, cross multiplication, so 2 sigma equals to 440, and you can divide it by 2 divided by 2, so sigma equals to 220. So if the question E, find the maximum possible value of the standard deviation, so the standard deviation is 220. The standard deviation is 220. Exactly, 220 to three significant figures. And the standard deviation here is 220. Yes, integer 600, 220. So, okay, so thank you very much for watching this video and see you soon. Thank you.